Yeah, hello everyone. Welcome back to our continuous solving the question number 22 and question number 23 of the 2021 fall session AMC12b. Okay, so I do think the geometry problem for this year's AMC is pretty simple. At least it's simpler than some years before. Okay, so yeah, let's see the geometry problem. So the right triangle ABC has side length of, okay, so we have the 6, 8, 10, right? So you know it's a right triangle. It's 6, 8, 10. So we know BC and AC, right? So C must be here and the B must be here, right? So this is 6. This is the AC is the 8 and this is the 10 here, okay? So it mentioned a circle at O is tangent to BC at B. You can think if any circle need to be tangent at B, what does it mean? Means where is this? Think about it, where is the center? Okay, when you tangent to that, right? The center is always the tangent point. From the tangent point to the perpendicular lines, right? And this always passing through the center. So the center must be here, right? So now you can see if the center must be on this line, right? So this line is parallel to AC, right? So you know then this is the 90 degrees, right? It must be here. And also passing through the A, right? So that means if this is the O, right? The OB and the OA will be the same. OB and OA will be the same where it can be. It must be on the perpendicular bisector here, right? So let's see, this is the M. And then this is the O, right? Okay, so good. Now we find the O, okay? So now next step. So we have this angle is alpha, this angle is alpha, right? So next is a circle centered at P is tangent to AC. So where is the center? The center must be lie on here, right? It must lie on somewhere 90 degrees, perpendicular lines to the AC, right? And also it need to passing through the B. So this line, the PA need to equal PB is also on the perpendicular bisector, right? Now we can see, okay, basically is this problem is very fairly is to let you think where is the center is, okay? Once we have this picture, then everything is simple, right? So we have 5, 5, you can see the OP, the OP, because we need to get into the two triangles, right? We can see OP is equal to the OM, PM minus OM, right? So you can see the PM, how to solve the PM, right? PM is in the right triangle AMP, right? So the PM is equal to the AM times the tangent of beta, right? Tangent of beta. So that's easy, right? 5 times the tangent beta is equal the 8 over 6 is 5 times 4 over 3, right? The same thing, and you can see the OM, right, as the right triangle and the MOB. So you can see the OM is equal to the BM times tangent alpha is equal 5 times 6 over 8 is 5 times 3 over 4, right? So now you can get the OP is 5, then 4 over 3 minus 3 over 4. So it is the 12 and 5 times 7 is 35 over 12. There, this is fairly simple, right? The answer is C. Okay, yeah. This one recap. Okay, you really need to think. Okay, to construct the geometry is to think where the center and what's the radius. Okay. Now the next problem. Okay, so it's another counting problem, right? and I think it's a stars and bars. Okay, so let's see what is the average number of pairs of consecutive integers in a randomly selected subset of 5 distinct integers. Okay, must be 5 distinct integers chosen from the set. Okay, you have a limited set to choose it. For example, 1, 17, 18, 19, 30 has 2 pairs. Okay, so we have one pair is 17, 19, and 17, 18, and 18, 19. Okay, so basically, if we randomly pick 5 distinct numbers from this set, okay, we want to see how many pairs it is, right? So let's see, we have m number of i's means, okay, means any set subset we take from here, right? We call the A, B, C, D, E. We take 5 numbers. Okay, this is the number of mi equals to the number of pairs, consecutive pairs. Okay, consecutive pairs. Okay, consecutive pairs within this subset. Okay, so if we can have 0, we can have 1, we can have 2, but what's the most we can have? 1, 2, 3, 4, 5, right? We have 1 pair, 2 pair, 3 pair, 4 pair. The maximum is 4, right? 3 and 4. If we can counting this, right? So the average will be 0 times uh, m0, 1 times m1, 2 times m2, 3 times m3, and 4 times m4, right? And divided by the total m0 plus m1 plus m2 plus m3 plus m4, then equals the average, right? Okay, so let's see how we can count it, right? Do we need to count the m0? We don't, right? Because m0 basic times 0, okay? So we only need to counting the bottom. I mean, the denominator is simple, right? Because sigma mi basically is all the ways how you can count how you can select the 5 element subset from 30, right? Okay, so it's 30 pick 5, okay? That's the denominator part. Now let's counting the numerator part. Okay, so let's counting. How about think? Let's counting about 1 pairs. Okay, so 1 pair you can think. Okay, so I have 2 numbers here. I have 1 number here, 1 number here, and 1 number here. Right? It must work in this way, right? So I have some data here, some number here, some number here, some number here, and some number here. Right? So you can think if I have x1 number here, x2 number here, x3 number here, x4 number here, and x5 number here. Okay. So now we can have x1 plus x2 plus x3 plus x4 plus x5. Okay, this will equal, we have 30 numbers, right? Take out 5 numbers, we have 25. Okay, but let's see the range of this, right? So we know x1 and x5 are greater or equal than 0, and x2, x3, and x4 will greater than 0, right? In order to do the stars and bars, we always like all these numbers are greater than 0, right? So how we can do this? So we can using the x1 prime equal 1 plus x1 and the x5 prime equal 1 plus x5. So now this one will be greater than 0. This one will be greater than 0, right? So using the star and bars, we can use the x1 prime plus x2 plus x3 plus x4 and then plus x5 prime is equal to 27, right? So how many such solutions? It will be 26, right? We have 5 numbers, we have 4 bars, right? Take it. Okay, so now we define, think about it. Now we define the number of numbers here, right? In the middle. We just define the number of each sections, right? And how we insert, how many ways we can insert these 2 numbers into here, 1 number here, 1 number here, 1 number here, right? So we have 4 ways. Okay, so this is why the M1 be very careful about this 4. Okay, so this is the M1. Okay, similarly, let's do the M2. Okay, I will box this. Okay, this is M1. We use a very similar way to counting M2. Okay, the M2 will be two pair. I can have this one, and I have two separate ones, right? Or I can have this one, and I have this one, right? But both of them, did you see, share the same structures? They have the x1 plus x2 plus x3 plus x4 is equal to 25, right? So this one is greater or equal than 0, greater or equal than 0, so that's why we change it to 27. So it's 26 over 3 bars, right? Now we can see, okay, if we have all these numbers or segment, right? How many ways we can insert in 311, right? There are 3 ways. And how many ways we can insert the second pattern is 221, right? There are also 3 ways. So that's why this is 26 3 times 6. Okay. Now the next one is the M3, right? Let's counting how many of the 3, right? So we can have 1, 2, 3, 4. That's 3, right? And we have one separate. Okay. The second one we can have is we can have 1, 2, 3, right? And we're adding another 2, right? So basically, this problem tells x1 plus x2 plus x3 equal 25. Again, this is greater or equal than 0. This is greater or equal than 0. If we expand it, it's 26 over 2 bars, right? And how many ways we can insert for 1? There are 2 ways. We can insert either here or here, right? Then how many ways we can insert these 2 patterns? There are 2 ways, right? So it's 26 pick 2 over times 4. Okay, now we get M3, right? Now we get M4, okay? The 4 is simple, right? The only way is 1, 2, 3, 4, 5, and something here, something here. You need x1 plus x2 equals 25, and both are greater or equal than 0, greater or equal than 0, so expand is 26 over 1. And how many ways we can insert pattern? There is only one way, okay? So by plug in all these numbers, okay? By plugging in all these numbers, okay? M1, M2, M3, M4, and the sigma is this, and what you can get, okay, go to your calculation, is 2 over 3, okay? So the answer will be A. The answer will be A. Okay, so recap is when we do the counting something like this, okay? If you try to avoid, I mean, the too complicated casework. Once you see too complicated casework, think in the other way. Can I use the stars and bars? Can I use a pi? Or can I use the recursion? Okay, these are 3 approach, very powerful tools, okay, to prevent you involved into too complicated casework. And also think about the complementary, right? Think if you counting like is like the space, is like how we divide the space, right? So we are counting, there's a total space, right? We are counting, we are cutting to here, right? We are counting this part, this part, this part, and this part. Sometimes that's too much casework, right? But if you see if you can counting the total, normally very simple, take out this one, right? And that's the complementary counting helps you. Okay, so yeah, that's the question number 22 and the 23. Okay, I will solve the 25 for 24 and 25 in the next video. Okay, yeah, thank you so much.